friends, in this video we will see a problem on effort lost in friction and load lost in friction. Here we have a question. Let's go through what is given here. In a certain machine, 100 Newton is lifted by an effort of 8 Newton at an efficiency of 62.5%. Find effort lost in friction and load lost in friction. This is the question which we have. Whatever is given here, I will write that in the form of data. So let's start with this problem. Now it is given in a certain machine 100 Newton is lifted, means 100 Newton is the load by an effort of 8 Newton. Effort is denoted by P at an efficiency of 62.5%. Efficiency is given. Find effort lost in friction, that is P suffix F, and load lost in friction, W suffix F. So this much is the data. Now let us start with the solution for this problem. Since the first question is effort lost in friction, so I'll start with that. Since effort lost in friction is given by, the formula is, it is actual effort minus ideal effort, because we know that actual effort will be more and ideal effort is less. The difference between the two gives us effort lost in friction. I'll keep this as equation number 1, because once we know actual effort, ideal effort, we can get effort lost in friction. After this, I'll say that therefore efficiency is given, so I'll write down efficiency is given by, efficiency is nothing but mechanical advantage upon velocity ratio, which we can say it is also equal to load upon effort into velocity ratio, because mechanical advantage is equal to load upon effort. So I have replaced MA with W upon P. Now therefore I will shift velocity ratio to the left, because velocity ratio we don't have in this problem. On right hand side I have W upon P. This efficiency will go into the denominator, so here I have efficiency. It's equal to, load is given in the problem as 100 Newton, effort is 8 Newton into efficiency is 0.625. So from this I will get velocity ratio first, and my answer is 20. Now after getting velocity ratio, I'll go for the calculation of ideal effort. Now just a small concept. Since for ideal effort, mechanical efficiency is equal to velocity ratio, because ideal effort will be there in case of ideal machine, and for ideal machine efficiency is 100%. It means mechanical efficiency, mechanical advantage is equal to velocity ratio. So therefore mechanical advantage is load upon effort is equal to velocity ratio. I'll shift P onto the other side, so W upon VR is equal to P. Since we want ideal effort, so here I have P suffix I. In short, this is the formula of ideal effort. Now I'll say that using the same formula, since ideal effort is given by P suffix I is equal to load upon velocity ratio. So therefore ideal effort is equal to, load is given in the problem as 100, velocity ratio we have calculated just now, it is 20. So from this, ideal effort comes out to be 5 Newton. Now if we look into the problem, actual effort is given, ideal effort we have calculated, so we can put all values in equation number 1 to get effort lost on friction. So I'll say that put P, that is actual effort, and P suffix I, ideal effort, in equation number 1. So therefore effort lost on friction is equal to P minus Pi. P is 8 and Pi is 5. So finally effort lost on friction, that is 3 Newton. So this is our first answer. The next part is they are telling to calculate load lost on friction. So again I'll say that since load lost on friction, it is W suffix F is equal to, now for load lost in friction, here it is ideal load minus actual load, because ideal load value will be more. Now again I'll use the small concept, since ideal load will also be there in case of ideal machine where mechanical advantage is equal to velocity ratio. So therefore load upon effort is equal to velocity ratio. Therefore load is equal to P into velocity ratio. Since we want ideal load, here I'll add suffix I. So this is the formula for ideal load. So here I'll say that therefore effort lost in friction is equal to, instead of ideal load I'll write down P into VR minus W. So here I have all the values. This is actual effort, value is 8, velocity ratio was 20, minus load given in the problem. The load is 100 Newton. This is actual load. So from this I would be getting the load lost in friction, and my answer comes out to be, this is 60 Newton. So this is my second answer. Now as we see into the problem, there were two things asked: effort lost in friction, load lost in friction. Effort lost in friction, the answer is 3 Newton, we have calculated. Load lost in friction, the answer is 60 Newton, that is also calculated, and with this we complete the problem.